We are asked to evaluate the indefinite integral as shown. We first observe that the integrand consists of powers of sine and cosine functions. Since these powers are both odd, we have a choice to use u is equal to sine x or u is equal to cosine x as shown to the right. We choose the first substitution simply because there is no negative sign. First, we prep our integral for the substitution. So the integral of sine cubed x times cosine cubed x dx is equal to the integral of sine cubed x times cosine squared x, because we're taking out one cosine x factor to make our substitution. And now we observe that our very first term in the integrand is actually equal to u to the power of 3, and that cosine x dx is equal to du. What about the middle term? For this, we need to recall the Pythagorean identity for trig functions. And so we see that cosine squared x is equal to 1 minus sine squared x, which allows us to make the substitution again that u is equal to sine x, and so this is simply equal to 1 minus u squared. Now it helps to actually rewrite our integral in terms of u before we continue, and so this becomes the integral of u cubed times 1 minus u squared du. And as we expand our bracket, we get u to the power of 3 minus u to the power of 5 du. These power functions are simple and straightforward to integrate, and we get u to the power of 4 over 4 minus u to the power of 6 over 6, since it's indefinite, plus c. Next, we write our answer back in terms of sine of x, and so this becomes sine x to the power of 4 over 4 minus sine x to the power of 6 over 6 plus c. Now, if we would have used the second substitution, our answer to this integral would have been cosine of x to the power of 6 over 6 minus cosine of x to the power of 4 all over 4 plus some constant, and since we used c already, let us use capital D. Now, graphing both of these solutions with Desmos, we see that these two functions only differ by a constant. You could also show this algebraically, but I leave that up to you.